Unfed half-wave dipole antenna has a high feed point impedance of the order of 2500 ohms. It is transformed to the 50 ohms impedance needed for the feed line coax and the radio using a 49:1 unun. Unun transforms impedance from the unbalanced EFHW to the unbalanced coax. We sometimes call it balun as well, though technically it should be called unun. Balun is one which connects a balanced antenna to an unbalanced feed line like coax. To check the efficacy of 49:1 unun or impedance transformer, we need to connect the 50 ohm side to the S11 port of the NanoVNA. Other side, which involves the antenna terminal and the ground, should be connected to a 2500 ohm resistor to simulate the high impedance of the EFHW. Then the SWR should be checked in the NanoVNA across the desired range of frequencies for which the unun is meant for. A nearly flat SWR tracing across the frequencies will confirm that the unun is transforming the impedance well. Here is the 49:1 unun connected to the EFHW, which I purchased from a local ham. The large toroid has two sets of windings which are interconnected. The upper side is connected to the antenna wire and lower side to the SO239 connector for the coax. A blue capacitor is seen across the central conductor and ground of the coax side. Now I have connected 2.2 kilo ohm and 560 ohm resistors in series so that the combination reads 2.7 kilo ohms in my LCR meter. Antenna wire was disconnected from the unun and the 2.7 kilo ohm resistor combination soldered across the output wire of the unun and the ground connection. Connected the unun to the NanoVNA using a short patch cable. Stimulus range was chosen as 3 to 28 MHz to cover 80 meter to 10 meter amateur radio bands. SWR sweep shows a flat SWR tracing. Prior to that, the NanoVNA was calibrated as discussed earlier. This short video clip shows the SWR sweep from 3 MHz to 28 MHz. The values for SWR are displayed at the top as the marker is moved across the frequencies. SWR is seen in the range of 1.25 to 1.5 along the whole spectrum of frequencies. This confirms that the unun can transform the high impedance of the EFHW successfully to around 50 ohms to match the feed line and radio. Power rating of this unun is 200 watts, which is enough for my work as the maximum output of my FT710 radio is only 100 watts. For higher power rating, thicker wires for winding the unun and stacked toroids may be needed for dissipating the extra heat generation. This simple bench test for the unun will not exactly predict its on-air performance. When the actual EFHW wire is connected and mounted, instead of the purely resistive load, we expect dips in SWR for all harmonics of the fundamental frequency. For example, if the antenna wire is 20 meter long for a fundamental frequency of 7 MHz band, it will show SWR dips on 7 MHz, 14 MHz, 21 MHz, 28 MHz and so on. Thanks to VU2 XPZ for this final clarification on air today morning.